Hi, I'm Rich with Inside HPC. We're here at the HPC User Forum, and today I'm here with Paul Messina from the Exascale Computing Project. How you doing today, sir?
I'm doing very well, thank you, Rich.
Well, great. Paul, we haven't talked since SC, but I was wondering if we could catch up a little bit. You recently had a meeting with a new advisory board of industry, wasn't it? Tell me more about that, could you?
Yeah, I'd be delighted to do that. Yeah, we constituted what we call an industry council. It's an advisory board, and industry here means not computer vendors, but it's primarily companies that use HPC, and many of which feel that they need exascale as well. A few of the members are also from software companies, companies like ANSYS that make software that many of the companies then use to solve their problems and design their products. There are currently 18 members, companies that you might expect like General Electric, General Motors, United Technologies, Procter & Gamble, and some you might not, such as Mars Candies and FedEx.
Oh,
Now those do because they have logistics problems, and some of which are very time dependent. So think of FedEx when there are thunderstorms and they still want to deliver everything on time. They have to marshal many planes, many trucks, and still get things done. So they have to very quickly do a very complicated graph analytics problem. So this industry council I see as having two benefits for us. One is they can guide us as we're developing the Exascale software stack and working with vendors to hopefully get better hardware design as to what their companies need, what would benefit them more. Because hopefully then we'll develop something that's useful not only to Department of Energy, NSA, and other federal agencies, but also to the companies. And so, by giving us their advice as to what would help them, that's a big benefit to us. So hopefully we'll be able to meet many of their requirements. And then the other is an independent set of people with typically very big industry who can demonstrate that they have a need for exascale, that it really is important for designing jet engines, wind turbines, all kinds of things. So this industry council had its first meeting in March 6th and 7th, and there was great engagement, and we look forward to working with them. We'll have in-person meetings every 6 months, and in between we'll have a video conference with them. So that's one of the many things that we've been able to do since you and I last talked.
okay. So, little segue here. Can you tell me more about the other progress you've made with ECP?
Absolutely. It's amazing how many things have, in fact, been able to get started. So when we last talked, we had sketched out a plan for software technology. And software, of course, is such a complicated and essential part of the project because it bridges the applications to the hardware. So we now have 66 software technology projects underway and funded. And they're working with the applications, of which we have 26 application projects, finding out what the applications need and then trying to meet their needs. In many cases, they have what we call a joint or shared milestone, because we want to avoid the perennial problem of people saying, here are my requirements, come back when you've met them, and things tend to not converge when you do that. Whereas here, it'll be an application that says, I really need a mathematical routine that has these features, this kind of performance and data structure, and then somebody who does math libraries, will try to produce such a piece of software for them. So we have 66 such projects, and they range from what you might expect: programming models, enhancing MPI and OpenMP, asynchronous task models such as the Legion programming language, down to many math libraries, and then runtime systems, tools for measuring performance, tools for debugging, visualization, you name it.
So the whole environment that you will need around this exascale machine, you're already working on that software.
That's
Yeah,
correct.
yeah,
Right, even though we, of course, don't know what the hardware will be like.
yeah.
But then that's another thing, as you will recall, we have the Path Forward program, part of Exascale Computing Project. And we are in the final stages of signing contracts with 6 companies, some of which then have additional industrial partners. And they will be doing R&D on better designs of hardware at the node level, the memory level, at the system level, and working with the software people and the applications people so that there's co-design, for real. So we'll have 6 of those. 5 of the contracts have been signed. And we're waiting for the 6th, and then we will announce all 6. So, so we have that underway. We also have the concept of co-design centers. I think we had identified 4 last November. And one gap that we've been wanting to fill, we now have. We have a 5th one that focuses on graph analytics. So again, we're moving towards a data-intensive, large-scale data analytics, and graph theory plays a big role in that, so we now have a 5th one. In addition, we are just now launching a proxy applications effort because, of course, the applications are big and complex, and for some of the R&D that the hardware people need to do and the software people, it's just unwieldy to always work with the full complex application. And so you have slimmed down versions, proxy apps, and so that's a separate new part of the project. We also have one that's focusing on productivity, and so it's the IDEAS project that Mike Haru and Lois McInnes have had, and now there's IDEAS-ECP, also just being kicked off right now, again, to help all those software developers and application developers do a better job, be more productive. And we've also launched something called Design Space Evaluation, which is a set of people who have tools for modeling and simulating new architectures before they're built, so that we can simulate what the path forward companies, for example, are designing, and before they go too far, try to figure out for our applications, in many cases using the proxy apps, this new architectural feature looks like it'll work really well or maybe not so well. So design space evaluation involves 7 of the labs, and they're using many different kinds of tools, abstract machine models, and some of them are almost cycle accurate simulations. So that's yet another thing that's going on in the project. We now have about 800 people doing R&D in all these things that I've been mentioning, and does not include the path forward because that has not yet been launched. So it's getting to be a big.
Yeah. Well, as you lay this foundation for these exascale machines, I think it's important to point out the RFPs for those machines are not out yet, are they? I mean, the actual machines that we're going to build, 3 of them, I believe.
Yeah, for the real machine.
Yeah.
That's correct. The RFPs are not out. Now, the project did issue an RFI in February, and it was a very broad RFI by design. The project issued it, but we did that in collaboration with the facilities at the DOE National Labs that typically have the biggest systems. So, Livermore, Los Alamos, Sandia, Argonne, Oak Ridge, Berkeley. And the RFI asked for information about, well, what do the vendors think they can build by 2021, which is when we hope the first exascale system will be delivered. 2022, 2023, which maybe a couple more would be delivered. And then even 24, because by then it'll be time for the next turn of the crank for one of the facilities, 1 or 2 of the facilities. So that was part of the RFI, and the long timeline was on purpose to make the point that we're in it for the long run, and so the vendors can look forward to many procurements, not just the first 1 or 2 or 3. Secondly, we asked questions such as, what path forward type research still remains to be done that, if we had money for, say, a Path Forward 2 program, would be worth funding to make the first couple of exascale systems even better. And also non-recurring engineering. As you know, when the labs recently, the last few years, they issue a build contract then they also issue a companion contract for non-recurring engineering, which is additional R&D to make the product even better. And so we asked in this RFI, what things are ripe for NRE and about how much, would it cost. So with all that information, which we're just sifting through, the responses were due March 31st, so we haven't had them for very long. That will help us and the facilities plan for the RFP. So to get back to your question, the RFP has not even been written, but the results of the RFI will certainly go into what's a realistic RFP, because you don't want to ask for things that are impossible, but you want to ask for as much as you think you can get and afford. So, it will be, we don't know yet when that RFP will be issued. I would guess about a year from now, perhaps less. And typically, of course, there are only a couple of months for the vendors to respond. It takes a few months to make a decision. And you can see that by that time, if it's 2018 and we want something delivered in 2021, we're about out of time. So you have to do it on that schedule.
Yeah. Yeah.
So we have no idea. Now, one great thing is that I think we had 18 companies respond to the RFI. Of course, they're not all going to be prime and integrators. Mm-hmm. But there's a lot of interest there, a lot of potential players. And so we hope to have a good number of vendors bidding on those first Exascale systems. And we have no idea who's going to win. Certainly nothing has been wired.
Right. Well, that's capitalism at its best, sounds to me. And boy, impressive amount of progress in a short amount of time, Paul.
Thank you. Yeah, we have been busy, but it's a great project. And, even though some things are uncertain, both the technical challenges that we have to face and then the funding challenges, our approach is always just go full steam ahead as much as we can, do the best we can, not pause and worry about, doom and gloom, just get our work done. And if we have to adjust our plans, then we will.